This is the Amp Hour Podcast. Released February 3rd, 2019. Episode 428. Setting Fire to the Tracks.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
Happy New January almost. Oh, sorry, February.
Yeah, February, right. Welcome back. Welcome back, friend.
Thank you.
Had a heck of a holiday, huh?
I did. I was on walkabout.
Nice. The Aussies you guys do that right, I gotta say. I'm envious.
We do indeed.
Yeah, it's good. It's good. But now you're back, and it's still beautiful weather out there anyway. So who cares, right? I mean, it's still.
That's right, and you're just shoveling snow, and they're setting fire to the train tracks.
That's right. Oh my God, you saw that?
I saw that.
Yeah,
What
so it is
the hell?
historic cold here. I was outside earlier. It was minus 20 Fahrenheit, so that's about minus 30, I think, Celsius, before wind chill.
I don't understand how and why people populated these locations. They get like this. Why?
I don't know. I didn't think it was going to be this bad.
I don't know, as we were talking about before the show, I don't know anyone who actually enjoys living like that, where they have to shovel their snow every morning before they can get their car out or whatever. It's just unbelievable.
I don't know what to tell you, man. I just live here.
Oh, goodness. All the more for working from home, I guess, right? You can just lock yourself inside and just piles up outside. And who cares if you can't open your front door?
That is today for sure, yeah.
Because I've actually heard of, like, overseas, like, especially when we have, like, subsidiaries overseas that are in these locations and stuff. Oh, the company's, no one's at work today because they couldn't get in the front door. It's piled up with snow. Like, literally, they couldn't get into the building.
Right. Well, and usually that's the thing, though. Like, so the places I used to work in Cleveland, it was like they wouldn't shut down unless it got really bad because they were always prepared for it.
Right.
You know?
Oh, okay. Yeah, of course. How do you prepare for it? Do you have like a company bulldozer or something to?
Yeah. Snowblowers are a big thing, and you have plowing service, and it's a whole big thing. I'm sure our listeners, some of the ones in the north can relate. And it gets a lot colder than it gets here too. So, like, you know, I know there's some people, I have some friends who listen to the show who are up in Minneapolis, and some people further north up in Canada, like Alaska, I'm sure. So, yeah.
Well, all you need is some solar freaking roadways to melt all your snow.
You're right, exactly.
Right.
Yeah. Yeah, the solar panels probably are really efficient in the cold too. So,
yeah,
that helps. That helps convert that sweet road sun into energy. Anywho, the more things change, Dave, the more they stay the same.
Speaking of which, has anything changed with you? Are you still doing the same, working on the same stuff?
A lot of the same stuff. I started doing that. I think that part I mentioned, that LoRa chip. I started working with that, and that's been good. I've been doing actually some dev boards, and getting a couple different dev boards up and running. I been fighting the good fight with a lot of getting started guides and stuff like that. It's still as bad as I remember, but
they shouldn't be. I mean, you know, that's the whole idea of these dev kits and getting starter guides. Is you're supposed to just be opening them up, and any dummy's supposed to get it working.
Right. Well, you know, I'm a special breed of dummy, Dave.
Join the club.
Yeah, right. Yeah. And I think one of my problems is that I always kind of get psyched out as well. So I'll like be like, it's something I'm doing. And so like this latest one, I was doing a Bluetooth dev kit, and it was like an NRF 52 dev kit or something like that.
Yeah.
And Alicia from the Embedded podcast was helping me actually troubleshoot. It was really great. And the end of the day, it was like I was struggling, trying all these different things, trying way too many things, honestly. And at the end of the day, it was because I had the board was labeled in the wrong bag, and I didn't actually look at what the part number was on the board. And so basically I was just trying the wrong setup the entire time. But the
You were
whole time,
trying the entire wrong board?
yeah, exactly. So it was like a
How does that work?
well, because it was like a NRF 852-832, right?
Yeah.
And I thought it was the 840 or 52
Oh,
840.
okay. Oh, okay.
And the
Right.
idea is basically because they compile differently. I kept trying and trying and trying, and the problem was that my self-talk was, I'm doing something wrong. I'm doing something wrong.
Yep.
And
of
the
course.
problem was, it was just like much more foundational than that. You know, it's like that
Mm-hmm.
needing to take a deep breath and step back and be like, okay, what the hell is
Check to
actually
make
going
sure
on
I've
here?
got the right device to start
Exactly.
off with.
Yeah.
Right.
And you know, of course, once that happened, it was like, yeah, then it worked fine, you know. But it was
Wow.
because of that self-talk, you know, and for people listening too, I don't know if other people experience this stuff. I psych myself out so often where I'm like, it's something I'm doing. It's something I'm doing.
Yeah.
And I mean, I guess I didn't check the board, so it was something I was doing, but it was not. I don't know how to follow a guide.
No, but it was
you know?
more. Yeah, it was more fundamental.
Yeah,
than
exactly.
that,
Right.
You know. Yep.
Yeah. So.
I can remember
Yeah.
once that I was on a website, can't remember what it was, you know, and you've got to enter in all your details, and it had, date of birth or whatever, you know, and you put in
Yeah.
all your details, and I couldn't figure out why this website wasn't working. It'd just say incorrect information, and I'm trying it like 50 times. And I had to do this. I couldn't abandon it. It was absolutely essential
Right,
to do
right.
it.
Yep.
And like it literally took me like half an hour to realize, and through all this other troubleshooting and trying different browsers and doing all sorts of stuff, that I realized I was entering today's date instead of my birthday.
I've done that.
Like my
Yeah.
brain just
Yep.
got in that mode.
Yep.
You know, and like
And David, come on, you were born. We were born yesterday.
right. I'll pay that.
Yeah.
Oh man, yeah, and it's
Yeah.
just something fundamental like that. But then my engineer brain kicked in and just started thinking about
Right,
all
right.
the other things.
I
it
wonder
could
if the
have been.
server's down. I wonder if it's this. I
Yeah,
wonder if it's,
yeah,
you know, like,
it's-
and like,
yeah.
exactly. You go over the top, and sometimes it's just that needing to step back and. Yep. But
Wow.
you know, you always learn something out of it, and so I definitely
I
learned
do.
a lot.
I always remember that. I
Yeah.
always it sinks into your brain.
Right. Well, and I think when you
Yeah.
do struggle, I mean, like, you know, I'm not a huge fan of the struggle, right? But like of
Right.
like going through a
Yeah,
dev platform and learning.
Adversary and
Yeah, well, and like just like learning all the different, like, because you know, you can read the cursory overview of like a dev kit and be like, all right,
Yeah.
click this, click this, click this, it works. And then at the end, you have a blinking light, and that's great, and you've like understood it. But it's kind of like what you talk about with like the I hope your project doesn't work. You know, it's like if it doesn't work at first, you're going to read the documentation a lot closer, because you're like, all right, where did I mess this up? You're going to try a lot more things. And then, you know, at the end, you're probably going to have a little bit more dopamine because you finally did get it working, even if it's something
of course.
kind of stupid. But out of that, you know, so I was asking around then, because I'm curious too. Like, so the reason I've been doing a lot of different platforms is and maybe I've talked about it here, is like I'm just trying to get tools in my toolbox. Like basically,
Sure.
I'm trying to build it up so to the point where like I need Bluetooth, it's this one solution. I need, you know, Wi-Fi, it's this other solution. Like I don't want to have to think about it. And like I think we've talked about before too, of just having that platform for that thing, and then you pull it out of your back pocket. You're like, yep, here we go, ready to go, no questions asked, because it's rock solid, whatever. I'm just trying to build up that mental model for myself. So that's why I'm trying all these
Because
things.
you need to, because you're in the contract design business.
Exactly. Yep.
So, yep.
And but I was asking other people like what their favorite stuff is, favorite part families and dev boards are these days. Let me send you this. I think it was a tweet. I'll send you this link. But it was great because like a lot of people were responding about what they're working on, and you know it's good to kind of just see what's new and what's out there. So there's a lot of people who are really excited about the ECP5, which is that new FPGA family from the a lot of the open FPGA tools. There's a lot of people talking about that.
Hang on. Who's the FPGA vendor?
That's Lattice.
Oh, it's Lattice. Okay,
Yeah,
right.
yeah. So this is when we had the Peter who did the remote correspondent thing for us over the holiday. So he was talking to Clifford and Dave, and they were talking about a lot of these. So basically, the new tools that Clifford Wolf was working on, and Dave and a bunch of people are working on. Basically, there's new tool chains that enable these FPGAs to go through. I still haven't looked into the MiGen, MIGEN, but I think that's like a generator tool for for FPGA stuff, right? So it's kind of like a higher level, Python toolbox for building complex digital hardware. So basically, it's
what's a Python to VHDL compiler or something?
I think Verilog. Yeah, I think it's basically it's like a scripting thing that allows you to do that. I literally just looked it up, but it's a FHDL, whatever that means, functional HDL.
Well, there's C to Verilog compilers as well.
Yes,
that allow you. Altium, has one of those that allows you to, just write your C code and then literally, convert to hardware.
Yes.
You push a button, convert to hardware, and it may not be optimized, but it's
Right. I think this is even higher level than that, because it's just like I want to do like a math function and put it into, make it hardware, right, to like really accelerate this thing. So. So a lot of people talk about that.
But it doesn't work for everything. Some things lend themselves to the parallelism nature of FPGA architecture. Other things don't.
Right.
You're better off just slamming it through a fast pipeline CPU.
Yep.
So.
Yeah. So let's see what else was on this list. So a lot of FPGA stuff. A lot of the there's a lot of all-winner type PCBs these days. There's actually one that's on the list that I had for us to talk about, because it's like there's a new one that's out. It's actually using RISC-V 64-bit processors in it, so really crazy.
Okay.
Another super cheap processor, CH554. That's another one. That's kind of like that what was the 3-cent microcontroller you did?
Yes, the Hadouk.
Hadouk. Okay.
Yeah, if I'm pronouncing it correctly. I don't think so.
Yeah.
But yes, Hadouk.
Yeah.
There's actually an active thread on the EEV blog forum, actually, hacking, actually reverse engineering their programmer. Because I actually spoke with the manufacturer.
Oh, that's right. They reached out to you.
We aren't going to release our tools. We aren't going to release the programming algorithm for our chips, So there's a lot of people out there trying to reverse engineer that just for kicks, because they like the concept of a 3-cent microcontroller.
Right. That is crazy cheap.
Yeah. But, realistically, for most of the stuff that most people work on, there's not much difference between a 3-cent micro and a 20-cent, or a 30-cent PIC or Atmel one, right? Yeah, yes, it does cost 10 times more, but in the scheme of a typical BOM, if you've only got 1 or 2 of them in your project, it doesn't matter. You might as well just use the 30 or 40-cent PIC.
Right. Yeah, unless you're making enough that the upfront cost of figuring that out.
Exactly.
Yeah, that makes sense.
Yeah.
Yeah.
But, how many designs have 100 microcontrollers on them? There's not many,
Is that what people are doing with? Like they're doing... Yeah. Oh, so like throwing a micro at everything.
Well, no. Most of them are just working on it because they think it's cool.
Sure,
most of them don't have an application for 100 microcontrollers in the one project, I'll tell you what's an interesting thing that we were just working on the other day, and we might do a video on this. It's on our list of videos to do, is that we're looking at the ARM ST micros, because we're using that for the new microsupply project, and we're looking at the aspect of we just realized that the chip we chose didn't have internal E² PROM.
Oh, right? Really? Okay.
And people, I guess, kind of take it for granted that a lot of micros, in addition to the flash program memory, they have internal EEPROM, where like a few hundred bytes or a few kilobytes,
storing constants and stuff,
program defaults when you power off and stuff like that. In this case, it programs which mode you're in. For example, when you change modes or you change voltage on your power supply, you want it to power up at the same voltage, right? So unless you've got a battery-backed SRAM, which is often the case if you've got a separate real-time clock chip, for example, that actually has a battery. Often they have like a few tens of bytes in there that you can use for storing a few little power on default things, so you don't lose the contents when you power off. But most of the time, it's completely volatile. And some micros, yes, you can write to the internal flash memory, right? So you can use the program memory to store data, but they've got a limited number of write cycles. And it's like, 10,000 write cycles or something. And that might sound like a lot, but if you calculate it, well, if you've got a power supply and you're always changing the voltage and you're always saving that voltage just in case they turn it off, right? It can be gone in 6 months, a year,
Right.
So that's the issue.
Huh.
And we're actually trying to think of all, if you were stuck with that, if you were really stuck with using the internal flash memory, what, little tricks could you do to get around that? One of them would be to have a roll-in
like a
code,
rotating thing.
Which,
Yep.
A
Based on date.
rotating code, either based on, just on the number of write cycles. So if you know it's 10,000 write cycles, then, and you've got enough program memory, then you can actually have a counter in there, as you could write a counter as well. And when it gets to a certain, say it gets to 9,000 or something, or, 10,000, you can say, right, I'm not going to use that section of flash memory anymore, because all these where-based things are based on the block of flash memory, right? So you can write to these different, so you don't kill the entire flash memory, you only kill that particular block. So you can actually wear level, like a lot of SD cards do this, they'll have wear leveling in them, and you don't know that these SD cards have these little wear leveling controllers in them that will decide where your data goes on the chip. Every time you download it, it'll like spread it across different parts of the NAND flash memory.
Wow.
And stuff like that. So, which is not, I don't believe that's in the SD card standard, but a lot of ones like SanDisk, they will actually implement these wear leveling algorithms. And I'm sure you'd get the same thing on solid state disk drives,
Does that mean you need to have more capacity than they actually publicize then? So like if it's a 2 gig card, they have 4 gig?
No, I don't believe so. No. But you need to, I don't know how the algorithms exactly do the wear leveling. I'm not sure, but I'm fairly sure that they don't actually require any significant amount of extra memory. Maybe there's a small overhead or something.
Yeah, okay.
To actually do it,
Right.
Yeah, just for, storing where things are or something like that. But I don't believe it's large. It's not like your 2 gig card's going to go to 1.5 gigs or something.
Right.
Because it's got wear leveling or whatever. So... so we thought about, different things about implementing that and stuff like that. But the reason I brought this up is because, it doesn't have internal E-squared prom. So we went, oh, look, can we upgrade to another model of micro that has internal E-squared prom? Because these STR micros, right, they make like 200 different variants, right? Yep. Yeah, right. It's ridiculous. And sure enough, even in the same family, if you get the /L, like the low power version, it's got E-squared prom. But the regular one doesn't. They're identical chips.
Yeah.
And the low power one has E-squared prom, probably because low power devices have to store stuff, maybe. I don't know. And anyway, it seems silly. But the price difference is like 40 cents.
Yeah.
Between the exact same chip, but one that has E-squared prom and one doesn't, right? That's a lot.
Hey,
40 cents, and we went...
I bet you're the only person doing this, though, right? I mean, that's probably they figured out where that pain point was. They're like, yep,
right,
that's worth it.
Exactly. And then, sure enough, we didn't even have to go to the Shenzhen market to get a cheap external E-squared prom. You just go to DigiKey, you can buy them for 4 cents.
Oh, really? Right? That cheap?
Yeah, that cheap.
Nice. Okay.
As in Atmel ones, Atmel / microchip ones. They've made E-squared proms forever, And even those on DigiKey are only 4 cents for an external E-squared prom. So it's cheaper to just get an external E-squared prom chip than it is to upgrade the micro.
Yeah, that makes sense.
Bloody ridiculous.
I was going to ask if there was other chips out there that might do it too. I know, I remember I always thought about FRAM, but that seemed like that never actually came down in price.
Oh, well, no, you can buy FRAM. David's a big fanboy of FRAM.
Right, but it's not cheap.
They've got essentially unlimited write cycles. And if you were writing, 100 or 1,000 times a second for some particular system reason, then you'd be using those. Right? You'd be using FRAM. You wouldn't use E-squared prom, because E-squared prom still has, even the best, still has, 1 million write cycles or something like that.
Yeah.
But it's certainly better than 10,000, that you might get in a micro. So... In the program flash memory.
Right.
So, that's... and, of course, micros don't need a lot of write cycles. They just haven't optimized them, because how many times do you have to reprogram your microcontroller? Not many, right?
Not if you're doing it right, yeah.
A few times. Exactly. And, yes.
Cool. That's great.
So, there you go. I thought that was interesting that it was 10 times... I thought, oh, no, just buy the micro.
Right.
That has it built in, but
How much are you guys playing on price with that
and
thing?
this isn't...
Like, is price of
What
like,
final price?
is like well, is like the 40 cents? Would that have been? Is that enough where you were like rather you spend some cycles?
Yeah, we're trying. Sure.
Yeah.
Yeah. We're trying to trim. You know, we're already adding so many bells and whistles. It's just getting ridiculous. You know, and everything adds up. So you know, the last thing I wanted was another 40-cent bomb item.
Yeah.
You know, so extra 40 cents on the bomb. So I'd rather have another part, physically another part, and then the extra pick and place cost, which is almost trivial. You know. Or it may not be. Just imagine if we were at, say, you know, 60 bomb pick and place items on our board, right? And the pick and place machine at the assembler only has 60 reels slots available, and then we added one more part and it took us to 61.
Machine, yeah.
Well, you need a either bigger machine, go to a different manufacturer, or they got to put the run through twice.
Right. That's real expensive. Right. Double setup.
Yeah, and they'll charge you for that.
Yep.
And they usually won't tell you any of that.
No, they'll just quote a higher price.
They won't tell you. They'll simply charge you.
Yep.
Yeah, exactly. So, how are your pick and place adventures going?
They are okay. I'm trying to think the last time we spoke about this stuff. I did use them for another high density LED board, and that definitely is that's definitely the best use case for me. I did actually.
Yeah, when you've got like 100 of the same part, you know.
Right. I have been talking to a couple. Yes, that's right. Yeah, so like 100. Yeah, so that was like I think 300 of the exact same LED being placed, and then I had like a panel of 4.
Exactly.
So it was like 1,200 placements in a row.
Classic use case. Yeah.
And so in that case, it was like I think I had three pick heads going, and it took about I think probably 5 to 10 minutes per board, so like a total of like 20 minutes per panel. So not terrible, but like that was also more of an academic thing.
How long did it take you to set up, do you think, estimate, like all up, realistically?
Yeah.
To set up that, as opposed to just going, bugger it, I'm sitting down and I'm placing 1,000 LEDs.
Well, that one is actually really bad because I kept having all these issues. So like the actual pick and place, like the files, like modifying the file, exporting the file, the position file, modifying to get the format that the Neoden wants, and remembering how to do all that stuff. That was probably two or 3 hours, right? Realistically, just because I was, it's not like I'm doing it often enough. The real problem was the first run that I did, I was flinging parts. It was pew, 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 like parts were just flying off everywhere.
Yeah.
And I was like, what the hell is going on? Because the first time I'd used that machine, it was fine. And it turned out it was because...
Didn't optimize the pressure?
Not even the pressure.
The height, the Z-axis?
It's the height, yeah, exactly. So I was...
Yeah, Z-axis, yeah.
I didn't realize
Which actually translates into pressure.
That's
right. If your height's not set correctly,
so if you're
push down
if you're
harder.
Pushing, you're trying to basically push through the board, and there's spring in both the board and in the nozzle, right? They're both there to basically say, okay, you want a little bit of pressure so that it releases right. I just hadn't set any of that stuff up right, and basically I had to go back and like set up from scratch almost at that point, and I'm obviously learning more limits of the Neoden machine. It's not a commercially viable machine in any way, shape, or form. But I did finally figure that out. There is actually for people that are interested, there is a new Neoden 4 video that's out from, apparently there's a distributor in the United States now. And so they made a pretty decent video. They still actually don't show one of the methods properly. So like they keep showing like how to place for a single board, but they don't actually show how to panelize in the proper way, and so that's something.
Right.
But the video is much more inclusive than the prior videos. So yeah,
got it.
I also started a forum. I had a couple of people I had email threads with, so I started a section on Contextual Electronics forum about that machine, and so if people want to talk about it, there's a section there now. There's probably about 6 or 7 people that are kind of talking through the particulars of their own machine, how to get it working well, so that kind of thing. So
cool.
I also learned there's a new Neoden coming out, like a Neoden 7 it's called. So it looks like it's probably they actually use commercial feeders, and so that's a big change and definitely going to be more expensive.
Right. What, some other brand feeder?
Yeah, I think it was like Casio, but it wasn't Casio. It was someone who's like a commercial brand who was like, oh, maybe Sanyo, something like that. Maybe Sanyo feeders.
Wow. As well, is it like a company that just specializes in feeders, or
Yeah.
another like a Yamaha kind of?
And maybe it was yeah, maybe I don't know. I don't remember who it was. But the idea was
Right.
this was a slightly better machine. Definitely more expensive. And I think it has 6 heads. It says here somewhere. But basically it's not included anymore. So basically it would be another cost. I think the eBay price that I'm looking at right now is $12,000 US. So without any feeders. So probably closer to 20K. Um,
Mm-hmm.
Oh, actually, no. This one actually contains feeders for 12,000 for like another 12 feeders or something like that. So it doesn't have a ton of them, but and it is Yamaha. Sorry, my bad. So track
Oh, okay.
and
It is Yamaha.
handle
Right.
with
Got
Yamaha feeders. So okay,
it.
yeah. So but again, it's not going to be something like you or I might be interested in this kind of thing. It's definitely like still accessible, or like something like MHub, like the space I work out of. They might be interested, but I can't imagine many individuals would be. And
No,
Yeah.
no, you'd have to be in a unique
exactly
situation
very
to want
very niche kind of
to
stuff.
your own personal 20K pick and place machine.
Yes, exactly.
Yep.
So interesting. Still interesting, I guess. It's So
Yep.
So that's my current state of pick and placeness. It kind of it ebbs and flows with like, so I've got another version of that board coming in, and I'm just gonna hand place it because it's not really worth the setup
it.
time. I think I did finally.
With the 300 odd LEDs.
Yeah, I mean, what does that take? Like an hour? 2 hours?
No, yeah, it doesn't take long.
Yeah, I put on a podcast.
Especially like because you would paste stencil it, right?
of course,
you would
yes.
paste it. Right?
Yes.
Yeah.
And that it always is that balance point. I don't know where that happens, but
Although it doesn't take you that long to hand solder either, right? All you got to do is go along and tin each row. Like I've done this. I've done like hundreds of LEDs, and you just go down and like tin one side of each one, and then boop place boop, and you can get. You can place one every 2 seconds or something.
yeah, exactly. It's annoying though. That's the main thing. It's like your eyes will get real tired.
It's pretty annoying. Your hand gets cramped up, and all sorts of yeah. But you can certainly do it.
Yeah. So it's it's worth thinking about. I don't know. It's I don't know where that crossover. I don't know where that crossover point is for you. Like, are you guys when you guys do prototypes? Are you gonna hand assemble, or are you gonna send out, or what are you doing for the?
Oh, we always hand assemble.
Yeah. Okay.
They're not that complex. It's it just isn't worth the grief. But we're actually going to do with the micro supply. What we plan on doing is actually doing a sort of like a pre-production run of like 10 or 20 of them, and then send them out to people so that they can use them and give us feedback and stuff like that. And we wouldn't do those by hand. We'd obviously get a small run done.
I've been thinking more and more. Like, obviously, I've been using a lot of the low cost PCB houses that are overseas, and I've just been thinking about it, like their costs are worth looking at least. I mean, I'm not right now. If you're listening to this, it is Chinese New Year. Happy New Year to anyone in China listening. Don't expect anything for another couple weeks. I definitely was like racing to get a board in at the end of last week. So we'll see if I actually get it in the next 2 weeks. But yeah, I mean, I need to. That's on my to-do list as well, is to just kind of give that a shot. Because like the costs aren't that bad, and there's a lot of the online ones like PCBNG and Macrofab and CircuitHub and all the ones we talked to.
JLC PCB do assembly.
Yeah,
and a lot
of them do.
All the big prototype houses have assembly services.
Right.
So
it's just more of like that control freak inside of me,
Yep.
And again, that calculation like you're talking about of like where's the balance point of like, is it just faster for me to order it and do it myself or whatever? So
right.
Yeah.
It's probably faster to do it yourself. Once you've got the parts, you just sit down for, even if it takes you a whole day, it doesn't matter, right? It's still going to be faster.
Right. And an hour, a day of my time is like, how much is that worth in terms of like the assembly cost? Maybe the assembly would be faster, but then it's like, even if you're doing the assembly, you gotta, make sure all your files are good. There's no backsies, right? If I order the wrong, if I order a 10K resistor instead of a 100K resistor, I can fix that on my bench by digging through my parts and being like, oh yeah, of course
Exactly.
I got a 10K, you know,
Yep.
or bodging something or whatever. If that happens elsewhere, it's like, oh well, let's have a meeting or let's do an email.
They'll just stop and they'll email
Yeah,
you,
exactly.
and then it's in the middle of the night, so you won't get the email until
Yeah.
the morning, and it's like, yeah, no.
Right. So yeah, maybe
Yep.
it's good for those 10 and above kind
Yeah.
of things, but it's still that valley of death, whatever they call it. So it's,
Right. Generally, any such issue that comes up, you can add 2 days to the time.
Oh yeah. Yeah.
You know, that's like, that's just the way it is.
Mm-hmm.
With communication turnaround in different time zones and stuff, you can, easily lose, 2 days.
Yep. Yep.
So,
It's good to get it right that first time. That's for sure.
yep.
As I will find out if my small change on my board, if it shows up before or after Chinese New Year, we'll see.
Because often, they don't, the assembler, for example, may not, or the PCB manufacturer or whoever, whatever, or assembly service you're getting done, they may not, like they may not encounter the issue and then immediately email you within
Right.
minutes,
Right.
right?
They do it at the end of the
might
day
just go,
or whatever.
and they'll do it at the end of the day. They'll move on, and because they're a production house, they've got to keep the production going. That's their number one requirement.
Right.
So yeah, at the end of the day, when they do their housekeeping, oh yeah, we had an issue with that board and we had to stop, and then you add in. That's why I'm saying 2 days minimum,
Right.
sort of.
I'm
turnaround
sure
for
that I'm
any
at the
issue.
top of their list, but maybe not.
Right.
Yeah. I'm nothing. Oh well.
Oh dear, oh dear.
Yeah.
Anyway.
I did want to bring up one other board from this list of the people tweeted back at me. I've lost it now, of course. But I also
Of course you have.
Yeah. But I also posted it to the forum. Basically, it was here we go. The Cypede. Oh, there's one I mentioned. The Risk V64, Risk 5, whatever. Sorry. Okay, here we go. This is a dev board. It's got a camera. It's got a dual core 64-bit Risk 5 processor on there. It's got a 2.4-inch LCD and a bunch of inputs and stuff. $18, $19.
$18.
Holy crap. So this is on Seed Studios.
Right.
But the reason I've been interested in this is actually not related to electronics as much as my holiday reading list. I've been reading a bunch of Yuval Noah Harari books. I don't know if you know who that is. He wrote like Sapiens and Homo Deus and
No.
stuff like that.
Yeah.
But he keeps harping on and on and on about AI, and so I got real worked up, Dave. Let me tell you, I got real worked up.
Tell us why.
Because it's like obviously it's a futurism book, and it's like nothing's gonna be as bad as they say, but also it's not gonna be as rosy as naysayers are gonna be. You know what I mean? Like, so
Right.
it's gonna be somewhere in the middle. And I was like started thinking about like, oh well, maybe I should learn about this stuff, and like from a good place. I think like I actually do want to learn about this, and this is what I wanted to say here because I think it actually has a lot of relevance to people in the electronics industry of like love it or hate it, like machine learning and whatever AI version of stuff that's out there, it all wants like sensor inputs. And that's
Yep.
kind of like the future, like basically any big data platform or anything like that. A lot of what we're going to be doing in the future, I think, in the electronics world is making data that's digestible by these systems that then makes decisions based on them. You could say that that's always been the case of what we're doing. But I was like, all right, well, I'm going to learn about what's actually happening in these in these systems so that I can make better sensors for it. And then that kind of put me down this rabbit hole. So one thing, this system was very interesting to me, the Cypede, because it's basically onboard processing with like GPUs and high-end chips and stuff like that. But then the other thing was I started taking a course, and I thought that was kind of interesting too, about machine learning. And it's actually very accessible. It's called Fast.ai. Have you ever heard of that?
Right. No.
It's basically like learning how to code up algorithms, I guess, but not really, but like how to do machine learning really, really easily. And it's pretty cool. And what I'm basically getting at is I would recommend that people that are interested in doing the electronics industry side of stuff start to learn this, maybe alongside me, if you're interested, because I think it's important to understand how a lot of the machine learning is happening, and then how it's going to be better, how you can make a better product that then can be digested by a lot of these algorithms.
Maybe, but I wouldn't recommend everyone just go learn it.
No,
because it the number of practical everyday applications where it's going to be practical to implement machine learning is still going to be small, right? It's not like, oh, your latest little pick widget is going to use, you're going to put machine learning in it.
That's true. Yes, that's right. Yes. No, yeah. And this is actually, so what I'm really talking about too is like thinking about how you collect and bundle up sensor data and then probably send it back somewhere. So that's really what I really mean. So yeah, you're right. You're not going to put anything. I totally agree that like putting machine learning down or like putting like high amounts of processing down onto like a battery powered platform, you're kidding yourself.
Yep.
Like it's maybe possible, but you're going to have a big battery and it's going to suck.
Right.
But I'm just generally interested in how the sensor side of things is going to end up impacting all this stuff. So one of the things I was thinking about is like, is it going to be possible to maybe take like an SDR or something similar? Maybe this is already happening, but take like an SDR, put like a
software-defined radio for those playing.
Thank you very much. And put it in front of like, so you take like a HackRF. Basically, you have a a 2.4 gigahertz device in front of it, and then you basically start to teach algorithms to detect what's going on there. That may already be happening, but like basically the idea that this course is starting to talk about is like even just taking visual processing stuff. A lot of that can be translated into learning patterns using a lot of this high level processing stuff. It's all happening on like servers and like GPUs and all that other crap. But I don't know.
This brings me to a point where you've got to be careful in engineering that you don't implement technologies and stuff just for the sake of it.
Sure. Yep.
Like sometimes like just keep it simple, stupid.
Yeah, I mean, if you're turning if you're like flipping a relay, right? It's not like you need some of this stuff. But I think that there's going to be more. I think there will eventually pop out some practical applications. So this is kind of more of a gathering tools now for potential implementation later, that kind of thing.
And people will do this in software too. All they need is like 100 lines of code to, for their little pick-based widget, right? But then they implement the full software engineering cycle of, so that it's, like 1,000 lines long, and they spend, 2 weeks on it instead of just writing the 100 lines of straight code.
Right.
Yeah. Yep. They do it all software engineering. If you know what I mean.
Yeah, like a lot of overhead and a lot of...
there's a lot of overhead is the term I'm thinking of, yep.
Yeah, so anyways, I was interested...
Oh, no doubt get criticised for that. Oh, but what's wrong with that? It's going to... troubleshooting down the... Whatever. It's extensible, right? Yeah. Sometimes it's just write your bloody 100 lines of code and inline code and be done with it.
Yeah, so, I mean, I was a bit circuitous talking about it, but I think this board's interesting because it is kind of like, I think it's going to basically push in both directions, right? Some people are going to be like taking sensor data and then immediately piping it up to a server and doing stuff on the server, and then they're going to try and push stuff down into the devices, and that's kind of like what this SiPED thing is. And there was actually, I saw that Espressif has a new board too. They have a camera-based board as well. Basically the same kind of, it's like really simple processing, but it's basically it can figure out where a face is, and then it can kind of track it. It has a camera built in. You seen this thing?
I've seen. There's lots of people doing this. Yeah.
This is like a dev board
doing this.
So like this is a $10 ESP32 development board. So that's kind of cool too. And a lot of them are targeted around running the, I forget the name because I was going to work on this years ago. I was looking into it. The Open Vision system. What is it? OpenCV?
God, there's a name for it.
Yeah.
OpenCV, is it? Yep.
Yeah. Computer vision.
CV.
Yep. Open computer vision.
Yep. Yes.
Yeah.
Exactly.
Yeah.
Yeah, because I was years ago, many years ago, I was going to do one of these, like a little module that had cameras and FPGA or whatever, some super whiz bang micro that was running OpenCV, right? And then it would, it'd be pre-programmed so that it could just do generic things that you needed to do, and it'd give you a simple output. Does this recognize motion?
Right.
Output pin goes high. Does this recognize a circle?
Right.
Output pin goes high. Stuff like that.
Is this a hot dog?
So-
Is this not a hot dog?
Yeah, exactly. And yeah, that was the dream. But yeah.
Huh?
Every man and his dog's working on that now.
Yeah.
Yeah.
Well, I think
Which is good.
Yeah. I think it's interesting. I think it's interesting to see where this is going to all go. It might go nowhere. I don't know. But I think the cheapness of it is usually like a harbinger of like, oh, well,
Yep.
it's really accessible now, so people will probably try it for a lot of things, and then a couple will stick, and yada yada yada.
Yeah. But the hardware's cheap, but the software isn't, right? The software pain is not cheap, right? Yeah, you may be able to buy your $10 module, but if you've got to do months of software development to get it to recognize a freaking banana,
Yeah.
right? Whereas if you can buy a pre-programmed module that you can just like set a bit which says recognize banana, and the output pin 1 goes high
the
when it
banana module.
recognizes a banana.
Right.
Right? Exactly. Right?
Right.
That's what I want. If I'm developing a system, I don't want to
branding's
spend...
going to go really sideways when they call it the banana eye, and they're like, oh, the banana pie, right? Yeah.
Oh, I love it.
I think the big setup stuff like you're talking about, I think one of the
Yep.
the differences is going to be like comparing the SciPede one and the ESP one. So one's actually an embedded version and one's an actual Linux version. And I think the Linux version are going to win. I think that obviously the power differences are going to be significant, right? So
Right.
but basically
But you just think the added flexibility is going to be the killer.
exactly. And like having like pre-compiled
Right.
solutions where it's like, people basically being able to step in and say, all right, well, I know how to work in Linux environments elsewhere. Now I can do this on an embedded basis. I
Right.
think honestly, just like the idea of having platforms that are more accessible for software people is going to always kind of changes things. I just
Sure.
yeah.
Yep.
So
Totally agree.
it'll be interesting. 2019 will be an interesting version of that. They still haven't figured out the friggin' battery thing though, right? I mean, like that's always what it comes down to is like
Power
yeah,
density.
exactly.
Power's a killer.
Yeah, it really is. Batteries still aren't get better, like but
Well, people forget how much power a Raspberry Pi takes.
yeah, right.
Like you think, oh, a Raspberry Pi, use that for any embedded application. 5 volts or 2.5 amps.
Right.
Thank you very
right,
much.
Exactly.
Right? That's freaking 10 watts,
Yeah.
right?
Yep.
It's nuts.
Yep.
That's a metric buttload of power for an embedded system.
Yeah,
That's
it's
just
not
nuts.
bad for a day on a battery, but a week, a month, a year, like yeah. Good luck.
It's not going to happen.
Right.
Yep.
Well, should we go to the list?
We have to.
We have to.
Now I'm jealous of this Hackaday article
Yeah, which one?
on circuit sculptures.
Oh, yeah. Wasn't that
I've
great?
always wanted to do this.
Yeah.
I've always wanted to do this, and I wish I had the talent to do it.
Yeah.
If there's one thing I wish I had the talent for, is to do some sort of sculpting.
Yes.
Something like, arty kind of stuff. Yep.
Yeah, this is a visual one, so people have to go click over to it.
Yeah, you've got to click.
I will
Yep.
also give a shout. I don't know if Mohit did it, but Mohit is, I think I'm saying his name right. He's he actually works for Particle, and he does a lot of their board design. But if people don't follow him on Instagram or Twitter, he does, I think that actually inspired a lot of this stuff, and some of his creations are just
Right.
unbelievable. So that's another.
Does it?
Yeah.
Does anyone in engineering use Instagram?
I used to. I've kind of cut it out of my life, but
Used to. Right. Okay.
But I think some people do. Why?
Right.
You do, right? No?
Well, I used to. Like, I set up an Instagram account. I've got, I don't know, 2,000 or 3,000 followers or something. And I used to post there because then it used to cross-post over to Twitter. But then I realized it was cross-posting lower resolution photos to Twitter automatically. Yep. So I thought, because I'm always posting photos to Twitter, right? It's one of the big things I do on Twitter is I'm posting photos all the time of everything. And, I thought, well, I might as well post to Instagram instead if it doesn't take any extra step. right? And it automatically cross-posts. But it just wasn't great.
Didn't deliver for you, huh?
It didn't actually deliver the image quality. You know, if I'm going to post an image, I want it to post a bloody image, not some 640 by 480 bloody, res stupid thing, right? I want it to post the original quality that I uploaded in, or at least near enough to it. Okay, it might compress it a bit, but I don't want it to resize it down to bloody nothing.
Yeah.
So, yep. So, I see his. Oh, I like that. Yeah, okay. Sorry, I'm just looking at some of the circuit art.
Yeah.
Yep, very nice. I can appreciate that.
Excellent.
It's beautiful.
Yeah, there's a lot of good stuff out there.
Yep.
And I guess we should probably describe what it is. So basically, it's like people using the connectivity points of either I guess
these are all through-hole paths. None of this surface mount rubbish.
Well, some of it's modified, but yeah. But basically, using the interconnects to actually form artistic links between them. So
yes.
Yeah.
They look fantastic. The wiring becomes part of the art.
Mm-hmm.
Yeah. And of course, and none of this, PVC covered wire crap.
Right,
these are like all exposed conductors running over each other and just making sure they don't touch because these aren't insulated.
Mm-hmm.
So they just, just run them over the top of each other. Just beautiful.
Mm-hmm.
Yep.
Yeah. So speaking of, not speaking of, I saw your discussion with your brother-in-law as well about patent stuff. I was just going down the list and my brain froze.
Right.
Are you guys thinking about patenting something? Where did that come from?
No. He just happened to be here. We were just hanging out, because the wives booted us out. So we went, we'll go hang out at the lab. Yeah. And I was about to shoot a little, which was going to be like just a 2-minute thing on the difference, because I did a teardown, and the difference between a utility patent and a regular patent, right? And then I thought, well, I've got a patent attorney here, may as well sit down. And then half an hour video later, we just started rambling on about. Yeah, exactly. So I just uploaded that as a separate video. So there was no intention, it just started out. What is the difference between utility? I thought I'd include that as a quick segment in my video, like 5 minutes worth, and nah, half an hour later we're talking about all sorts of crap.
Yep.
So
that'll happen.
Yeah.
Yeah, I liked your video about the. I was watching the one about how to be. It was kind of like a recap video, but like how to get into engineering. That was good too.
Oh right, yes, because I was stunned. I did a 5-hour live show the other day,
which is crazy.
Which is nuts. I just blinked and like 5 hours had gone by. I was wondering why I was.
I said it was pent up video energy after your long holiday, but
no, yeah. I've got that energy every day.
Sure.
I can just do that every day. What? You don't believe me?
You
want me to do a 5-hour live show?
5 hours for a week.
5 hours a day for a week.
5 hours a day for a week. You do that.
That'll be my entire.
And I will solemnly swear.
What's the bet?
I will solemnly swear that the chip printer will never become a thing.
Jeez, that's tempting.
I know, right?
Because it's on the bloody list this week.
Is it really?
Yes, the chip printer's on the bloody list.
I didn't see it.
It's down the. Did you add it? Where is it?
Oh, Z-Glue. Yeah, this is someone else. Grendel Key posted.
Right.
Yeah, this is like a new. Someone else posted about this. So Z-Glue is kind of like it's like building blocks for doing chip design. It's not a chip printer though. It's basically it's a way to piece together blocks. I mean, this is kind of how they do a lot of design, anyways. I think.
Yeah.
But you still need to make it at some point.
Yeah. It's not going to happen.
Right.
Yeah. No, that was going to be one. I was going to do a video on why a Mars planet settlement is not a thing. Like as in
like terraform.
Like as in no, not terraform, but why if your goal to set up a colony on Mars is to just in case this planet destroys itself, right?
Oh yeah.
There is no way that's going to work. They'll just die out in 50 years because they can't make. People just don't realize the amount of resources and energy that goes into making even the most trivial product here on Earth.
Oh yeah. Yep.
Right, and then once that thing fails, like a chip, for example, you don't know how much just the stuff that goes into making one chip. You can't replicate that on Mars. Right. So if your chips fail,
right, it's a supply chain
that's
problem.
It.
Right?
it's exactly.
Yeah. A long distance.
Yeah,
FedEx is in a new business now, right?
we have 1 billion people on this planet working towards producing stuff, and it's just like you just can't replicate that. On right. Mars, so it's not going to happen.
Well, until we can replicate it,
if you set
up
a colony on Mars, exactly. Yeah. It's going to be 500 years minimum.
Wow.
Like it's hundreds of years. If you think it's going to happen in 50 years, you haven't thought about the problem hard enough.
Well, there is that whole exponential thing, but I think it's yeah.
No, it can't. If you set up a colony, even with the most advanced technology, and you left it there, how when stuff fails in 20 years? 30 years, 50 years. How are they going to replace it? They can't.
Yeah.
They literally cannot. It'll devolve. They will devolve into animals, fighting to survive, right? They will devolve back into apes, It's like...
this actually is there's actually a good link that actually is tied to this. So someone linked it to me on Twitter the other day, but the history of Japan's electronic industry. Basically, so this is from... These are like 1980s, like late 1980s.
When Japan made all the best stuff.
Exactly. Yeah. And basically it was like the history, though. And it's showing a lot of the, so it's basically still early days of semiconductor processing, relatively. It's not like, but, just showing the energy inputs and specifically showing how Japan struggled in post-war days of like, there wasn't as much knowledge sharing. I thought there was a lot more knowledge sharing going on, but basically they were kind of reinventing a lot of stuff based on papers they saw after the fact. And so like they were doing like crystalline structure. So like the first thing they showed, like they were like 4 or 5 years, I think, behind the first transistor, where they were trying to do point contact transistors. But they were doing it based on the small snippets of information they got through the ministry.
Oh, so they just had to reinvent everything.
So this is amazing because these videos are actually interviewing the guys that were doing these experiments over and over and over again. It's so good.
Yeah.
And then the thing you'll love is part 3 is the calculator war, so it starts talking about that and how they.
Oh yes. Yeah.
So these are really good videos.
I think somebody linked that. I got to watch it.
Really good videos. But so like to your point about like the being on Mars, you don't really realize another thing they talk about in those videos. Is just like the purity needs for silicon-based processing, right? And as they struggled doing that, and
even the most rudimentary ones, I'm talking like 1970s chips, right? 1970s density, 5 micron stuff.
Oh yeah, but this is that era of like getting high purity.
But I'm talking but like a Mars colony, right? If you go there and you use your new ARM processors with their 10 nanometer process,
sure.
How are you going to you can't even replicate 5 microns fab on Mars, let alone bloody 10 micron.
Yeah, you'd be more worried about like breathing and eating and all the other stuff rather than making a clean room and processing stuff. Yeah, I do agree with that. I think that I was thinking just like, so say you wanted to do new silicon chips, right? How would you refine silicon on Mars, right? Like how would you do that? It would be very, very difficult.
Exactly.
There's like you were talking about, like there's just so much energy input, even the amount of energy input. So say you wanted to make, let's say like you wanted to make more photovoltaic cells, right? So basically big PN junctions.
But that's solvable. We could get a fusion reactor in 50 years, right? That could be a thing.
I believe they've been saying it's 50 years away for the past 50 years, so yes.
Hey, but no, seriously, that is orders of magnitude more viable than a semiconductor fab.
You're saying from the energy input perspective?
No. Just from the technology needed, right? No, it's just from a problem to solve. Right? How do you, set up a semiconductor fab on Mars as opposed to designing a fusion energy reactor, right? I think the fusion energy reactor is easier.
Well, I don't know how to do. I
think it's potentially easier.
I've worked in one. I haven't worked in the other, Dave. So
No. But if I had to bet which one was easier, I'd be betting on the fusion reactor.
Yeah, but I don't understand why. Because you're saying that the constraints
Just
of
because it's
complexity?
the energy. I'm talking about the energy problem, right? The energy production problem is more easily solved than the ridiculously orders of magnitude more complicated
It is complexity.
aspect of production supply chain for something like a chip, or even something like the clothing you wear.
Yeah, that's
or
true.
or anything
Right,
else.
How are you going to
right?
get?
It's just
how about like you're not going to be able to ship deionized water, and so you'd have to make deionized water. You'd have to make even just stuff like alcohol, rubbing alcohol for cleaning things, right? So if you needed a clean environment,
Right.
you'd have to make every single thing.
there's hundreds of different
Yeah.
things. Hundreds of different things you need.
Yeah, that's a really good point. Yeah. I hope you make that video. That actually would be really. You watch this video.
Yeah.
This might be good fodder into your video because this was a very well done video.
Well, I think this if I do the video on that, it's just got to be a rant. If I try and research it, it's a week long rabbit hole.
Oh, sure.
It's like
Yeah.
no. So either you just rant about it and let the people find out in the comments, or you if you want to try and explain it with data and facts to back it up, it's a week's worth of research.
Yeah.
It's just crazy.
Yep.
So I'm not going to spend a week on a rant video. Anyway, back to the video before we tangented. The video about getting into engineering. That's the one you talked about, wasn't it? Yeah. I was doing the live stream and I couldn't believe, over 5 hours, people just kept asking the same question over and over again. How do I get into engineering? How do I become an electronics engineer? Not just engineering in general, but how do I become an electronics engineer? So I thought, this is, I just got sick of repeating myself over and over during the 5 hour live stream. So I just decided to do a video.
That's great.
On it, and
and I think it's things that we've talked about here too,
positive.
right? Of like bringing stuff to the interview, and I mean, obviously, people should go watch it. It was a good condensation of knowledge. I like that. I like that a lot.
Well, it was more food for thought, really. It's like encouraging people that no, you don't have to go down some formal route to become an electronics design engineer.
Oh, I agree.
know?
I agree.
You can get into the business any way you like.
Yeah.
There's more than one way in.
Right.
So,
right.
yeah. It doesn't necessarily mean that's the best way. It's like whichever way works for you. Just to give people, there's a lot of people who just felt stuck, that, I can't do my degree. It's too expensive, or it's too hard, or I'm too old, or I'm too, I can't do this and that. And it's like, well, you don't have to. There's other ways in.
Yeah, I think it's that. I think it's the idea of the first job, and I think that getting that first gig, especially if you don't have, it's always that chicken and egg of well, how do I get a job if I don't have experience? How do I get experience if I don't have, that. It's always that hard part of that. And I think that you're right, though. I think it's about taking on a lot of the work. Maybe even pro bono, maybe low cost. Maybe you're just trying to find anything out there, but basically taking on some work.
Yep.
And stretching yourself a little bit, and then hopefully that turns into something else.
Yep.
But
and there's a lot of people out there who made the argument, but you need to get the degree to get your first job, and it's easier if you go through the formal process, get your formal degree, and then it's easy to get a job. Well, I know a lot of degree qualified engineers who can't get a job, right? Who have trouble getting their first job, whereas others who don't breeze straight through and get a job straight away without even trying. It's horses for courses. It's a matter of how much work you're willing to put in, and how you're going to actually approach it.
Well, I always try and encourage people that are, some people are in it for the science and they want to get all the way through. They want a PhD. If they know that at the beginning, it's like, okay, well, that's a different thing.
Of course, there's only one way
but
to do it.
I think that if people want to be an engineer, I think that focusing on getting practical experience, getting hands-on, regardless of or if you're doing it the way you're talking about, or doing it through a co-op or an internship or whatever, I think that's really.
Yep.
You just got to have a focus on getting real experience as soon as possible. Even just to know if you like it, right? I mean, or figuring out what you don't like, because there was a lot of jobs I had where I was like, don't want to do that for the rest of my life,
Right. Yeah, of course. Of course.
Some things I liked.
Well, it's a job. That's the thing. That's the reason it's called a job, is because that's something that somebody else didn't want to do, and that's why they're paying you to do it. Right?
Yep.
Yep. But there's no, like, the thing I hate is when people make an excuse, oh, but I can't get my first job because I don't have the experience. And it's like, it's a chicken. I hate the chicken and egg argument. It's bullshit. You go out, you do the work and do your own work and make your own experience.
Make your own egg, damn it.
For it. Exactly. Yeah. And it's trivial in today's connected global e-commerce world to do this.
Yeah, right.
Right?
I think,
it's so incredibly easy to go work on your own project, and you don't need thousands of dollars.
I agree with that, but
or you can go help out on some other open source project.
I think the important thing, though, is like something like you were talking about, though, is like giving like the almost like permission that it's like, no, it's okay to just do your own thing first, right? I think a lot of people I think a lot of the traditional educational model is, there's gatekeepers and you apply to get past the gatekeeper,
right,
and in doing so you also learn some things. But that's always been, sometimes there are real reasons for that kind of thing, and I think there's some in place for engineering, but I think not as many as people perceive. And I think ultimately that's what you were talking about. You're saying that there are gatekeepers.
That's what I'm talking
you don't
about.
Need
there
to go
are
through
other
them.
avenues.
Right, exactly. There's a way around.
You don't need to go through them.
And I totally agree with that.
There are benefits to going through them. And
I think there are some
that was the gist.
Opportunities that are not available unless you go through them. Right. So if you want to go.
Of course.
If you want to go work in, and I think like the majority of people that are in those roles will have gone through that that main path, right? So like if you want to go be like a chip designer, right? Most of the time, you're going to go to a university, you're going to go through VLSI classes and
most of the time.
And do that stuff. Sometimes you're going to be Jerry Ellsworth, and you're going to but Jerry is the exception in that case. Now both are possible, and but they're definitely there's just different paths, right?
Yep.
So yeah.
Agreed. Because I did a video.
That's right. Yeah, it's good. Of course you agree. I agree with you agreeing. There was another there was a link to one of your videos. I didn't actually see the link, but I really liked the original thing for it. So basically at the bottom of this PCBchecklist.com, there's a link to your number 1129, creating nice readable schematics. So that's the one.
Okay.
But this is a new website that just popped up. PCBchecklist.com. Basically, you can go and contribute to it. So if you have stuff that you're like, hey, this should be on the list. This person, I think it's Heinrich, is maintaining this list of what should you be doing before you send out your PCB. And I think this is great. I've actually I wrote about this back in the day, and I was looking for something like this, and I'm really glad this is out there. And some of the stuff is simple, right? So like, are there pull-ups on an open collector, right? I mean, like, are there are you within your like sometimes just like there's a book that was a couple years ago. It was like The Power of Checklists or something like that. But basically, like when an airplane pilot, they don't need to know that the flaps, they assume that the flaps are working. They know how flaps work, but the reason they're doing it is because the power of it is to check each and every time, and you have multiple people checking in as part of the process and as part of like the routine. And that's the really important thing. And I can tell you the amount of times that I've forgotten putting a power LED on the board, really stupid stuff. But if it's on a checklist, and I go past it and I get through to my prototype and I'm like, where the hell is the power LED? That's on me,
The problem with a generic list like this, and it's already starting to show, is that it's so massive
huge,
that you can't possibly go through the checklist, because it's virtually it becomes infinite.
Right.
It becomes
but I think this is a good starting point.
And,
so people that want to, they want to take this. You can. So it's on GitHub. You can go and fork it if you want. You could start your own, that kind of thing. But I think that's a good start.
See, it'd be nice if there was some way. I don't know if this is possible. I'm just floating this idea of that you put in, like, maybe you could sort it by like what type of design are you doing? What's important to you? Is this a how critical is this board?
Right.
Like, I've worked on boards that are like, 16 layer, gigantic, like 400 millimeter by 400 millimeter, boards that literally are the entire $10 million project hinges on that one board working.
That's fun.
Right? Like, I am not kidding.
Yeah.
Right? Yeah, it's terrifying, right? That has a much different set of requirements than
Yeah, 2-layer nothing board that you send out to...
Arduino hat board that, exactly. Right? So if there's some way to sort of like sort the importance, but I don't think there is. Once again, I think there's a million permutations of
course,
that.
right.
So,
but I just like it because it's a good starting place for, like, you could probably go through and cross out. Like,
of course, you got to have
I'm not doing a high-speed design. I don't need to do 3.4 point B or whatever through 0.6 or something. You know?
So it's interesting.
Yeah.
All right. Well, I think that's our show, isn't it?
I think so. I mean, there's...
speaking of which, there's a last-minute one. Bill, a friend of the Amp Hour, Bill Hurd, he did a video for Hackaday.
High-speed design.
Testing myths of high-speed PCB design.
That's great.
I think he was wrong on one point, though, and I did post it in the comments.
What's that?
Sorry, Bill. He said that there's a difference in the impedance whether or not the trace goes horizontal or vertical on the board because of the glass weave, and I don't think that's correct. Because there is a difference. There is a difference in the positional location of the trace, because if you've got a loose glass weave board, because they're cheaper, right? If you don't know, a typical FR4 glass PCB, FR4 is the flammability rating, but that's the generic term we use. Anyway, a board is made of basically glass and epoxy.
Right. Yep.
Right, which is a glue. So they combine this glass weave, which gives it its rigidity and its strength and its dimensional stability and blah blah blah. Right, and its warp, its inability to warp and all that sort of stuff. So this glass weave, so it's like a fabric, and they weave it in both directions, and then they encase the whole thing in epoxy basically, and that's how they make your board. Well, if the glass weave costs money. Right, it'd be cheaper if they just poured the epoxy, right, without the glass in it. It'd be cheaper. But, of course, it adds glass, adds all the stuff. So what they do is they do, like on cheap boards, cheap FR4 quality boards, they'll do like a really loose weave. So there's actually gaps between, so it'll be like a checkerboard type pattern. Yeah. You can call up there's a screenshot in his video. It's a checkerboard type pattern. And if your controlled impedance trace happens to be above the glass weave, then it's going to have a slightly different impedance than if it's above the one that has all the gaps. Right. But the gaps between there.
Right, because just a different coefficient, basically.
It's a different dielectric coefficient, exactly. So, and it varies, and it's a real thing. And Bill actually demonstrates in the video using a TDR. And
cool.
And that's cool. But he claimed that it was a horizontal vertical thing. But if you actually look at how the weave is manufactured in the board, it's actually a symmetrical layout. So I think what he was seeing is the difference between the slightly offset trace. It wasn't the fact that it was horizontal or vertical.
Okay.
Anyway, I put that in comments, so please jump in there. And that was my initial thought when I watched. I didn't watch the entire video right through. I was kind of like skipping through, and I just saw that he mentioned that.
Cool.
And
that's. I mean, I like this kind of stuff too, because this is something where it's it's a vanishing number of people that are going to get into this level with their designs, but
of course.
I think that number grows over time as just boards get more and more.
Oh, it does. Yep.
High speed.
Everyone's hooking DDR up to there, but then if you're doing that, most people aren't at the board, like they're going to be using like a module.
Right.
They're going to be using a pre-done module where it's all laid out for them. So the technology is getting more accessible, but most people won't be laying out DDR4 memory onto their microcontroller.
If you're coming from the software world right now, don't freak out. Don't freak out. This is what me and Dave do when we get to software. We freak out. Don't freak out about the hardware.
Exactly. Yep. Because you just don't have to. Most, there's so many options to just avoid doing that.
Yep.
That's not funny. So, Anyway, yes, that was a really good video. I like that.
Yeah.
And maybe we're talking in the background about a possible collab.
Ooh, nice.
So,
okay.
we'll see what happens.
That's great.
Yeah.
All right.
That might
Well,
happen.
there are a lot of other links and many more links to Dave's stuff too. There's a Roden Schwartz thing. Yeah. So lots of links from the past 6 weeks, month and a half. I don't know, since 2018. So we'll talk about more of them in a couple weeks here.
Cool bananas.
All right, man. Talk to you soon.
Catch you next time.